Hello my dear students. So we are discussing hydrostatic pressure and its application. In the previous chapter we did a few activities to understand how hydrostatic pressure is. So from that you all can remember the hydrostatic pressure or pressure exerted by the liquids depends on the depth of the liquid column, and when the depth increases the pressure exerted increases. And also we saw that the pressure exerted at the same level is equal, and also the pressure exerted at the same level in different directions is also equal. Thereafter we understood that the pressure exerted by a liquid column depends on the height of the liquid column, not on the shape of the liquid column or the amount of liquid present inside the container. So those were the conclusions or the understanding that we got from all the activities. So I told you all in this chapter, I will start by deriving the equation for liquid pressure. So if the height of the liquid column is h and the density of the liquid is rho. Now that letter is rho. Rho is used to denote density. The weight of the liquid column above a unit area of the bottom surface of the container is h rho g. So this is what we need to derive. Now if we take a liquid column like this, a liquid column. So this is the height of the liquid column h, and the density is rho, density of the liquid, and this area is a unit area. So because of that we will take it as 1 meter squared, we'll say. So that is a unit area 1. The unit is 1 unit area. So from this, if we are to calculate the density, before we calculate the density, we calculate the weight of the liquid column. So here, what are the values given to us? The height of the liquid column, the density is given, and they have said the area is a unit area. So how can we find the weight? You all can recall. Weight is equal to mass into gravitational acceleration. And mass, how can you find from all these? We have the density. You all know density is mass over volume. So if we write the equation for density, you all know it is mass over volume. So if we rearrange, mass is equal to what? Density into volume. That is one equation we are going to use. Then you all know weight of a liquid, weight is equal to mass into gravitational acceleration. So these are equations that you have learned before. You all know those equations. So using these, if we find the mass of the liquid column, that is equal to what? As I told you, mass is equal to density into volume. So we know the density rho. Then we need to multiply it by volume. But here you all know, students, volume is equal to what? Height into area. Height into area. Depth, length into breadth into height is the volume. So density into volume, that is equal to, volume is equal to height into area. But here we have said area is equal to 1. So volume is going to be height into 1. You all have to remember that. So if I substitute that here, now this is something that we need to remember. So if we use that here, rho into, instead of volume, we can write 1 into height. This is 1. Area is 1 unit, so it's 1. 1 into height. So we can come to that equation. Then, if we are to find the weight of the liquid column, so from this, we can also write it as rho into H. We can leave out the 1 because when you multiply by 1 also, you get the same value. So, density into height. That is the mass of the liquid column. So, weight of the liquid column, that is equal to mass into gravitational acceleration. So, there we have found the mass as rho into H. Then you need the gravitational. You need to multiply by the gravitational acceleration G. If we rearrange this, we can write it as H, rho and G. So, that is the weight of the liquid column. So, here weight, but this weight is acting on a unit area. So, how did we define pressure? We define pressure as force acting on a unit area. So, we have found the weight, that is the force exerted by the liquid column on a unit area. So, what is the pressure exerted by that liquid column? It is going to be H rho G. So, here we can say the weight of the liquid column is the force exerted by the liquid column on a unit area. Therefore, the pressure exerted by the liquid column can be given by pressure equals H rho G. Is that okay, students? If we go back, so here you can see this is the container. It has a unit area. The height of the liquid column is H and the density is rho. So from density, you all know, students, density is mass over volume. Therefore, mass is equal to density into volume. So mass of the liquid column is rho into volume. But as you know, volume is equal to height into area. Area is a unit area, that's 1. So, volume becomes height into 1. So, therefore, when you substitute that in the equation, density is into 1 into height. That can be written as density into height, that is rho into H. So, from that, if we find the weight of the liquid column, that is equal to mass into gravitational acceleration. We have found the mass of the liquid column as rho into H. So, that is rho into H. If you multiply it by gravitational acceleration, that is H rho G. So, we have found the weight of the liquid column as H rho G. So, from that, You all know, students, the weight of the liquid column is the force that is exerted over that area. So, it is the force exerted by the liquid column on a unit area. Therefore, the pressure exerted by the liquid column can be written like this. P equals H rho G. I am sure you all can understand that. So, with that, students, I will move on to the next slide. So, this is an equation that you have to remember. P equals H rho G. When it comes to hydrostatic pressure or pressure exerted by liquids, it is equal to P, pressure equals H rho G. So, here also you can see, students, it depends on the height of the liquid column, the density of the liquid column, and the gravitational acceleration. Again, in the next slide also, I will elaborate this. As we are concerned with the pressure on the base of the column. So, here we consider the pressure on the base of the column. So, you can remember, students, liquids exert a pressure on the base as well as the vertical walls. But here we are getting the equation, or we are concerned on the pressure exerted on the base of the column. We divide the force by the area. So, what I showed you all before. Since this weight spreads over a unit area, the liquid pressure at the bottom is H rho G. So, this is what we derived. The liquid pressure at the bottom is H rho G. This result is true not only for the pressure at the bottom, but for any other depth of a container. So, here, if we look at this height, the pressure at this height will be H rho G. If you have another height from here to here, or at this point, let's say, if this is H1, then the pressure there will be P equals H1 rho G. The density and the gravitational acceleration are the same. Density is the same for a certain liquid. Gravity is a constant value. So, it will depend on the height of the liquid column. We said that before also. When the height of the liquid column increases, or let's say the depth of the liquid column increases, the pressure increases. So, you can understand that from this equation. P equals H rho G. Since G is a constant, rho is a constant for a certain liquid, when the height of the liquid column increases, the pressure exerted by the liquid column will increase. So, based on this, if there is a liquid column of height h above any point in a liquid as shown below, then the liquid pressure P at that point is given by P equals H rho G. The equation I told you all that you have to remember. Is that clear to you all, students? P equals H rho G for liquids. So, in this, if we consider the height in meters, that is the standard unit m. So, rho is density. What is the unit of density? Standard unit kilogram meter minus 3 kilogram per meter cube. And gravitational acceleration you all know the value, students. The exact value is 9.8 meters per second square. But for convenience of calculation, we take it as 10 meters per second square. So, the unit for height is meters. Density, kilogram per meter cube. And gravitational acceleration is meters per second. So, using all those units, if we try to derive the unit for pressure, pressure equals H rho G. So H is going to be in meters, rho is going to be in meters per second squared into I will rewrite that. Rho is density, that will be in kilogram per meter cube, and gravitational acceleration meters per second square. If I rearrange the unit, student, we will have the meter here into, I'll bring the meter minus 3 there, that into kilogram meter second minus 2. This you all know, mass into gravitational acceleration is weight. So that is equal to newtons. And over here we have meter into meter minus 3, that will become meter minus 2. So what is this unit going to be? Newton meter minus 2. That is the unit that we got first for the pressure exerted by solids. And that is equal to what? Pascal. After the scientist, Pascal. So this will be equal to Pascal. Pascal. So the unit is derived after the name of the scientist. P has to be capital, A is simple. So standard unit of pressure exerted by solids or liquids, or even for that matter gases, is going to be Pascal. Pressure, the standard unit is Pascal. You have to remember that, student. Standard unit of pressure is Pascal. Is that clear to you all? Now if we go back and look at this. So from what we derived before, if we consider the force exerted by the liquid column, that is equal to H rho G, but that is spread over a unit area. So because of that, the pressure becomes H rho G. So that is the equation for pressure. So in this also, the pressure exerted by a column, a liquid column, will depend on the height of the liquid column. When the height increases, the pressure increases. And also, pressure depends on the height as well as the density of the liquid. So when you change the liquids, the density will change. Because of that, the pressure exerted will change. The same way, if you have the same liquid, when the height changes, the pressure will change. But gravitational acceleration, you know, is a constant. From those, if we look at the units, height is given in meters, density kilogram per meter cube, and gravitational acceleration meters per second. So using those values, if we try to derive the unit here, P equals H rho G, so meters, kilogram meter minus 3 into meters per second square. So I rearrange the equation, meter into meter minus 3. I took the kilogram here. So this becomes Newton and this becomes meter minus 2. So Newton meter minus 2 is the unit that we get for pressure. But that has been given the standard unit Pascal. So Newton meter minus 2 is equal to Pascal. That is the standard unit of pressure. So I am sure, students, you all can understand this equation clearly. So if we look at an example, if you have a liquid column, say if we say the height of the liquid column is 2 meters, and if this is water, you all know the density of water, 1000 kilogram per meter cube or 1 gram per centimeter cube, but that is not the standard unit. So we need to use the value 1000 kilogram per meter cube. And you all know the gravitational acceleration 10 meters per second square. So students, if you are to find the pressure exerted at this point or the bottom of the container, How do you find it? We write the equation P equals H rho G. Always start with the equation. The H is given to you 2 meters. What is rho? 1000 kilogram meter minus 3. And acceleration 10 meters per second square. So when you multiply all the values, you will get the answer as 20,000 Pascal. So you all know the units when the height is in meter, density is kilogram per meter cube, and gravitational acceleration meters per second. The unit for pressure will be in Pascal. So you need to multiply all the values and you will get the unit as Pascal. I am sure you all can understand that clearly. With that, students, I will move on to the next slide where we will discuss some examples. Example 1. This is given in your textbook. It is a worked example, but I will explain it again. At a certain location, the depth of a certain point in a lake is 1.5 meters. Find the pressure exerted by the water at the bottom of the lake at this location. So, the height is given to you as 1.5 meters. Then density of water is given to you, that is rho 1000 kilogram meter minus 3. And they have given the gravitational acceleration 10 meters per second square. So, if you write all the values, it's easy to do the calculation as well. And also, you can look at the units. This is in meters, okay, kilogram per meter cube. And students, you have to be careful with the density. If it is pure water, you all know it's 1000 kilogram per meter cube. We will look at some more examples where the density of water changes. If it is the sea water, salt water, the density will change. So, you have to look at the value there. Then, of course, gravitational acceleration. Then, what do? You need to write the equation. Pressure, or you can write it as P equals H rho G. So, here you need to substitute. H is given 1.5 meters. Rho 1000 kilogram meter minus 3 and G 10 meters per second square. So, when you multiply all the values, you will get the answer as 15,000 Pascal. Why 1.5? So, 1000 into 10, the answer will be 15,000 Pascal. I am sure you all can understand this calculation. It's a direct calculation. You need to remember the equation. Pressure equals H rho G. Is that clear, students? So, then I'll move on to the next example. Example 2. The depth of a certain region of the sea is 10 meters. So, here when they say depth, we consider it as the height, H rho G H. So, here H is 10 meters. Then density of sea water, as I told you, is given as 1050 kilogram per meter cube. And gravitational acceleration 10 meters per second square. What do we need to find? Find the pressure exerted at this region by the sea water. So, again, you use the same equation. Pressure equals H rho G. So, what is H? 10 meters. But density is different. 1050 kilogram meter minus 3 and 10 meters per second square. So, here, if you multiply, it is going to be 105,000 Pascal. Is that okay? 1050 into 10 into 10. So, 105,000 Pascal is the pressure exerted by the sea water at that particular point or at that particular depth. So again, a direct calculation. You write the equation, substitute the values and find the pressure. Okay students, so this is how you calculate the pressure exerted by a liquid column. So with that, I will move on to the next topic where we try to understand how pressure is transmitted through a liquid. Transmission of pressure through liquids. So when you exert a pressure at one point of the liquid, that will be transmitted through the liquid to a different point. That is what we say as transmission of pressure through liquids. We will observe how that occurs. Liquids do not get compressed by forces exerted on them. This you all can remember, students. Now in your smaller grades, we have looked at compressibility. So we take a syringe if it is with air. If you hold the open end of the syringe where you put the needle, if you push the piston, air gets compressed. But if you try to do that with water, it doesn't happen. So that means liquids do not get compressed. But when you push that liquid, we will be exerting a force. So force over unit area will be exerting pressure. That pressure will be transmitted through that liquid. So that is what we will discuss here. So liquids do not get compressed by forces exerted on them. Therefore, the pressure exerted at one point in a liquid can be transmitted to another point in the liquid. A machine constructed to operate based on this principle is known as hydraulic press. You have to remember this term. Hydraulic press is the machine that uses transmission of pressure through liquids. So this is a diagrammatic representation of a hydraulic press. Now look at this diagram properly. Now on this side, there is a small liquid column. The area of the liquid column is less. You can see here it is 10 centimeter square. Now that same liquid column here, it is a common base. So the same liquid flows through here. And on this side you can see the area of the liquid column is more. So we have two cylinders, one with less diameter, the other one with a higher diameter. They are connected, so the liquid flows through it and also it is a continuous column of liquid. Here you have the column and the liquid continues here and you have the column there as well. So this is what we are going to do. We have a piston A on this side. So what we will do is, we will apply a pressure of 20 Newton on this piston. You push the piston down. So you all know what will happen when you push the piston down. This water will be pushed down. At the same time, we will be exerting a pressure on this water or the liquid. So that pressure will be transmitted through the liquid here, through this area, and it will be transmitted to the other cylinder where it will push this second piston up, that is piston B. So there we will be able to exert a different force. So by applying a force onto the small piston or piston A, we will be able to generate a greater force in piston B. That is the concept of hydraulic press. We will try to understand that with a calculation. So here you can see, students, 20 Newton force. So what is the pressure here? Pressure is force over area. So force is what? 20 Newton. Area, we will use the unit. Area, we will use the unit centimeter square itself. So the pressure you can see 2 Newton centimeter minus 2. I am not going to do a unit conversion because we are trying to understand the concept, not to calculate the pressure in standard units. So 2 Newton per centimeter square. So every unit centimeter, there will be a force of 2 Newton acting. So that pressure, 2 Newton per centimeter square, will be transmitted this way through this liquid. Again, the same pressure will be exerted there. So, on this piston also, piston B, the pressure is going to be 2 Newton per centimeter square. But the area of the piston is greater. So, again, if we write the equation for pressure, force over area. So, what is force? Force is going to be pressure into area. So, that means force is going to be, pressure is 2 into 200 centimeter square. So, therefore, the force becomes 400 Newton. That is what is shown there. So, by applying a 20 Newton force here, the pressure is transmitted through the liquid and that exerts a force of 400 Newton there. So, this piston, the large piston, will be pushed upwards with a force of 400 Newton. So, can you understand that? You apply a small force, 20 Newton. That becomes 400 Newton there. Why? Because the area is less here, 10 centimeter square. Here the area is 200 centimeter square. And that is possible because liquids transmit pressure. Is that clear to you all, students? So here you have to remember another thing. Now so far we have discussed there is pressure exerted by the liquid column also. Now in this calculation I only considered the pressure exerted by this force. So here of course students we ignore the force exerted by this liquid column because you will see as examples of hydraulic press, the hydraulic hoist, the hoist that is used to lift vehicles in service stations. There you all can remember students or you all know students that the weight of the car is very heavy. So to lift that weight you need to exert a very high pressure. So when compared to that pressure, the pressure exerted by this column, this liquid column is very much less. So therefore we can ignore that and we carry out the calculation using the force exerted here, not considering the pressure exerted by the liquid column. Because you all know as the depth increases, the pressure also changes. But that can be ignored. Is it clear to you? So what do? We apply a small force over a small area that is transmitted through the liquid to a piston where there is larger area. Because of that, the force with which the piston is pushed up is greater. But the pressure is the same. Why? Pressure at the same level is the same. So here you have the liquid level here, the same level here also. So pressure at the same level of liquid is the same. Pressure is 2 Newton centimeter squared here. Here also pressure is 2 Newton per centimeter square. Is that clear to you all? That is the function of a hydraulic press. Okay students, so now you all have understood this concept. We will try to observe this in the lab. I will do a small simple activity so that you all can understand how pressure is being transmitted from one piston through the liquid to the other piston. You all can observe that clearly. So let's go to the lab and do the activity now. Okay students. So now we are going to observe how pressure is transmitted through a liquid. What is the machine that is used using this principle? It is the hydraulic press. But when we use that concept to lift a vehicle, we call it the hydraulic hoist. So first I'll demonstrate how pressure is transmitted through the liquid. So to do that, I have two syringes. So you all can see students, this is a large syringe with a piston here, and this one you can see is a small syringe with a piston. Now in both you all have to observe clearly the liquid level. Again here I am using colored water so that the changes are more clearly visible. So here you can see the piston is in contact with the liquid, and in this cylinder also you can see the piston is in contact with the liquid, and throughout the tube, that is through which the pressure will be transmitted, there is liquid, that is water. So what do we know now? I will apply a force to the small piston. Then you will have to observe what happens. When I press the small piston, you will have to observe what happens to the larger piston. So now you can see when I am applying a force, can you all observe the large piston? Slowly as I press the small one, the larger piston is being lifted up. Can you all see that? So if I release the pressure again, now you can see again the force acts on the other side. The large piston comes down. So from this, you all can understand that pressure is being transmitted through the liquid. So how do I transmit pressure, or how do I apply pressure? When I give a force here, there is the area, the cross-sectional area, a small area there. With that area, I apply a certain amount of pressure. The same pressure will be transmitted through the liquid to the larger piston. Now here, if you look at the area, you can see that's a larger area. So you all know pressure is force over unit area. When the pressure is the same, when you apply a small force here on a small surface area, the force that acts on the larger area will be greater. We will be discussing calculations related to this as well. So here again I'll demonstrate. When we push this piston, you can see the large piston rising up. So their pressure is being transmitted through the liquid. And also there is a liquid column here. Now compared to the pressure exerted by this liquid column, the pressure by the force I apply is greater. Therefore, we neglect the pressure exerted by this liquid column in the large piston as well as the small piston. So we only consider the pressure exerted by us by exerting a force. So that concept is the hydraulic press. So now again I'll bring it back to normal. So we can observe how the hydraulic hoist is functioning. So here I have a car just to demonstrate what happens. So students, for us to observe it more clearly, I attach the car. You all know how the hydraulic press functions. Now this is the hydraulic hoist. The same principle, and we will see how the vehicle is being lifted up. So here of course I have connected the large piston to the stand so that it's easy for us to observe. Now I have the small piston here. Now you all can see there is a liquid connecting it. So then what happens when I apply a force to the small piston? There is pressure generated, pressure is exerted to the liquid, that is transmitted to the large piston, and therefore there will be a force acting on the large piston that will lift the vehicle up or hoist the vehicle up. So here you all can observe clearly students when I apply a force to the small piston. Now here you can see the car is being lifted up. So as we apply the force, the car goes up. When we want to release it, you can release the pressure, apply the force in the opposite direction. So here you can see the car comes down. Now that is the function of a hydraulic hoist, the normal hoist. But here students, you all have to remember, now this is a toy car, so a small amount of water was enough to hoist it up. But for a real car, the weight of the car is more. So to apply that amount of pressure by applying a force to the small piston, we transmit the pressure, but we need a higher force acting upward so that the car, the real car or any vehicle for that matter, will be hoisted up. So to do that, it is difficult to press the small piston, because then you will need to have a very tall liquid column inside the small piston and you have to keep on pressing it for a longer time. So to facilitate that, what they do is, in the real hydraulic press, they use a compressor. Now the compressor pumps liquid into this small piston. Instead of pressing it down, they pump the liquid. So by pumping the liquid, they exert a pressure to the larger piston. So easily the vehicle can be hoisted up. So that is the function of the hydraulic press or hydraulic hoist that we see in the garages or workstations. Okay, students. So now that you have understood very clearly how this system works, we will try to understand more of this and then we will look at some examples as well. It consists of a liquid volume trapped by two pistons A and B on either side of a cylindrical liquid column. So the liquid columns are cylindrical in shape. They are connected together and there are two pistons A and B on either side. You all can remember that. Assume that the area of piston A, so piston A was on this side. Area was equal to 10 centimeter squared and on this side we had piston B. So their area of piston B is 200 centimeter square. So we change the area. Accordingly, the force will change. If a force of 20 Newton, so if a force of 20 Newton is applied on piston A, the pressure it exerts on the liquid. So we already calculated that, but I will do it again here. So here the pressure is equal to force over area. That is equal to what? Force is 20 Newton divided by 10 centimeter squared. That will be equal to 2 Newton centimeter minus 2. So as I told you before, students, I am not going to convert the unit to meters because we need to compare the pressure. So we leave it as Newton per centimeter square. So 2 Newton centimeter squared is the pressure. So using that, we can calculate the force here. So again, pressure equals force over area, but we rearrange to calculate force, pressure into area. Pressure is the same as here. Why? The same pressure is transmitted and the pressure at the same level of the liquid is the same. So there are 2 Newton centimeter minus 2. Area is going to be 200 centimeter minus 2. So that will be equal to 400 Newton. We have done the calculation before also. So applying a force of 20 Newton, you are able to lift or exert a force of 400 Newton. That is how the hydraulic press works. So with that, I'll move on to the next slide. This pressure is transmitted to piston B through the liquid. So all what I explained before is given to you here. Therefore, pressure at piston B is also 2 Newton centimeter square. So at B also it is 2 Newton centimeter square. That is, the fluid exerts a force of 2 Newton vertically upwards. So you push the piston A down, but on piston B, the force is exerted vertically upwards on each 1 centimeter square of piston B. So you can remember the diagram, students. So we have the small piston here and we have the broader piston there. They are connected. So this is A, this is B. That is what happens there. Therefore, the total force exerted on the total area of 200 centimeter square of piston B is 400 Newton. 2 into 200. it is possible to transmit a force of 400 Newton to the larger piston from a total force of 20 Newton acting on the smaller piston because it is possible to transmit pressure through the liquid. So, since the forces acting on the pistons of liquid pressure machines are very high compared to the force due to the weight of the liquid column, the force exerted by the liquid column is not considered in calculations. I told you all that also before, students. So, you can understand here we push with 20 Newton force that is exerted or transmitted through the liquid, and here the piston is pushed vertically upwards with a force of 400 Newton. Here we apply 20 Newton, we push the piston down. Here the piston moves upwards, vertically upwards with 400 Newton force. That is because pressure is transmitted. And as I told you before, since the forces acting on the piston of liquid pressure machines are very high. So here normal pressures in the machines are very high. That is why we do not consider the pressure exerted by these two liquid columns. That is negligible. So that's what I told you all before also. So I'm sure with all this explanation, you can understand the function of a hydraulic press correctly. So now we will look at some examples where this hydraulic press or the transmission of pressure through liquids is used. Hoists that lift vehicles in motor vehicle service stations are built based on the principle of pressure transmission through fluids. Figure given below shows the principle of operation of one type of such hoist. So, this is the hoist or what we can call as hydraulic hoist. Again, look at the diagram, students. So, here we have one cylinder with a small piston. You can see this is a small piston. So, you are going to apply the force from this side like we did in the previous example. So, here we push the piston down. So, when you push the piston down, you can see from this position, it goes down. So, this is the distance moved by the piston A. So, the piston A is going to push the liquid down. You can push it up to here. Thereafter, you cannot push it because to this level, you can push the piston down. So, what will happen? There will be a pressure exerted on this liquid. That pressure will be transmitted through the liquid. So, the arrows has to show the pressure that is being transmitted. So, here the pressure is transmitted to this point and that will be transmitted up. But when it comes to this point, here you can see the area is more. Why? At this point, area is greater. Because of that, the force that is exerted vertically upwards. You can see the arrow there. It's exerted vertically upwards. That is a greater force. But you can see here, students, the distance moved is somewhat smaller compared to the distance moved here. Can you all see that? Why is that difference? The volume of the liquid. So, we have a certain volume that is being pushed down. That will be pushed to this side and pushed up through the second piston. But here, when the area is more, when the area is greater, the height or the distance will be less because the volume is the same. So, we need to move the small piston to a longer distance, whereas the large piston moves only to a shorter distance. But we can exert a higher force. That's very important. A greater force is exerted. So, we have the piston B there, the large piston, that will be able to lift a vehicle. You all have to imagine this. Some of you all would have seen this being done. Some of you all, you have to imagine this. When you exert a small force, now you can't exert a force to lift a car on your own. But here you're pushing the piston down. With that force, the vehicle is being lifted up. So to that extent, the hydraulic pressure is useful. Transmission of hydraulic pressure. Can you all understand that concept? So we exert a small force, the same pressure is transmitted through the liquid. Because the area is greater, we are able to exert a higher force and lift the vehicle up. But the distance moved by the small piston is greater. Distance moved by the large piston is smaller. So to carry a very large weight and to make it to move to a somewhat larger distance, we will have to move this piston to a very long distance. That is sometimes not practical. So therefore, in the hydraulic hoist that they have in the service stations, what they do is, instead of using a liquid column like that, they have a compressor to pump oil, and inside this they use the oil as the liquid. So by pumping oil, they are able to exert the force. So then they don't have to move the piston to a very long distance. We will discuss that in the next slide as well. So here this is the function. The hoist is constructed in such a way that the pressure generated in the oil, so here it is the oil that is used, through the small force applied on the small piston is transmitted to the large piston through the oil, transmitting a force equal to the weight of the vehicle placed on the large piston. This force lifts the vehicle. So you have the piston A, you apply a force, that pressure is transmitted and the vehicle is placed on piston B, the larger piston, vehicle will be lifted up. However, in order to lift a vehicle, the small piston must be moved by a large distance. This is what I explained. The small piston must be moved by a large distance. Because this is difficult, in actual hoist used in service stations, the small piston is replaced by a compressor that pumps oil into the small cylinder. So there the force is exerted by a compressor. Into the compressor they pump oil and that exerts the force. That generates the pressure. Pressure is transmitted through the liquid and the vehicle is lifted up. So the concept is the same. Only thing, practically to do the function, instead of applying a force, they use a compressor. So I am sure students, you all can understand that function. So hydraulic press is the concept or the machine that operates based on transmission of pressure. The first example is the hydraulic hoist. With that, I will move on to the next example. That is a jack or hydraulic jack. So it is a jack. Here you can see this is a hydraulic jack. You all know what a jack is. A device or an instrument that is used to lift one side of a car or any vehicle. If you want to change the tire, if there is a puncture, you need to change the tire, you use the jack to lift that part of the car, that side of the car up, so that you can easily remove and fix the new tire. So out of the different types of jacks, one of the commonly used one is hydraulic jack. From the name, students, you all can understand the hydraulic jack also uses the concept of hydraulic press. A jack is used to lift one side of a vehicle when a wheel of the vehicle needs to be detached. Out of the many types of jacks available, the type that is most frequently used is the hydraulic jack. Such a jack shown in the figure. Such a jack is shown in the figure. The hydraulic jack also operates on the principle of pressure transmission. So here what do? You would have seen this being operated. You have this handle here, you move the handle. So while moving the handle, what do? You exert a small force on the small piston. That will be transmitted through the liquid contained inside the jack. And that will exert a force, higher force on this larger piston. This is the larger piston. That is used to lift one side of the car or the vehicle. So by applying a small force, you are able to lift a heavier force or a heavier vehicle. Here also a force is applied on a small piston. So here also a force is applied on a small piston. The pressure caused in the oil by this force is transmitted to the large piston through the oil, lifting one side of the vehicle. Is that clear to you all now? So the concept, the basic concept is the same. Hydraulic press. The first example, hydraulic hoist. The second example, hydraulic jack. Similarly, we have another application, that is the hydraulic brake. So now that you have understood the function of the hydraulic hoist and the hydraulic jack, we will move on to the next one. Another instance where the principle of liquid pressure transmission is applied is the brake system in vehicles. So we call it the brake system or the hydraulic brake system or just hydraulic brakes. Its principle is shown in figure below. First look at the figure. Now here you have the driver inside the vehicle. You have the brake pedal. So when you want to stop the vehicle, you press on the brake pedal. So there you apply a force on the brake pedal. That is connected to this part. From there, that particular force is transmitted to a piston here. And this is connected to a master cylinder. And that master cylinder is a small cylinder or it has a small area. Master cylinder, small area. Small area. So there is a liquid. So you can see the piston with a small area when we apply the force. So here you can see, students, we have the small area, the small piston. Then there is the liquid. The pressure will be transmitted through this liquid. The liquid is known as the brake fluid. So through the brake fluid, the pressure will be transmitted. Then there is the slave cylinder that has a larger piston area. So with that, what will happen? The force will become larger, and here you can see the brake pads are connected there. So the brake pads will be pushed towards the wheel. So here you can see this is the disc brake. Because it is a disc-like structure, it is called the disc brake. And when the brake pads come and touch or press the disc brake will stop moving. So with that, on this side, it is the tire of the vehicle that is connected. So when it is being pressed, due to the force applied, the brake pads touch the disc brake stops rotating, and the tire also stops rotating. Therefore, the vehicle stops. That is how we apply the brake in vehicles. So here also, the force or the pressure is transmitted through the liquid. So that is why we call it the hydraulic brake system. You apply the brake from here. Force is transmitted to the small piston. That is given to the liquid in the master cylinder. Pressure is transmitted through the liquid, comes to the slave cylinder where the area is high. So here high area. So because of that, the force applied becomes greater. That is enough to stop the vehicle. In the brake system of a vehicle, when the driver applies a force on the brake pedal, students, you all know this brake The brake system or the brake pedal is this. In the brake system of a vehicle, when the driver applies a force on the brake pedal, it is transmitted to the piston in the master cylinder. This force exerts a pressure on the oil inside the cylinder, and this pressure is then transmitted through the oil to the slave cylinder near the wheel. Then the brake pads connected to the slave cylinder are pressed to apply a pressure on the brake disc or brake drums. So, there can be brake discs or brake drums. Since the cross-sectional area of the slave cylinder is larger, so here you can see slave cylinder is larger than that of the master cylinder. The force applied on the brake pads by the slave cylinder is greater than the force applied by the driver on the brake pedal. So, you all can understand that. With the force applied by our legs, we are able to stop a moving car. So, that is possible because of this system. I am sure you all can understand all these concepts clearly. So, in this chapter, students, we started this chapter by deriving the equation for pressure exerted by liquids. And we did a few calculations. Thereafter, we discussed the transmission of pressure through liquids. The concept is known as the hydraulic press. And as examples for hydraulic press, we looked at hydraulic hoist, then we looked at the hydraulic jack and the hydraulic brake system. So, those are all examples. With that, students, I am going to end this chapter, and in the next chapter, I will discuss some questions related to this topic and thereafter continue with the pressure exerted by gases.